My name's Kevin Wilcox. I'm at the University of Wyoming, and my role in the project is to help design the data collection efforts, as well as help get experimental infrastructure up. So as you can see, we have a number of rainout shelters that are blocking different amounts of rainfall. And the way we do that is we put clear plastic paneling over the plots, and we cover different areas over these plots. And they're clear so that so the light can get through the plastic, and we're having minimal effects on other attributes of the system. And so we have a gradient from no rainfall exclusion to 100% exclusion. And this allows us to look for thresholds in how the system responds to different levels of drought. And we're actually doing this for 2 years. A lot of landowners have extensive experience dealing with single-year droughts. They happen pretty frequently, but as higher variability in climate occurs in the future, we're likely to have more and more of these multi-year droughts. And so understanding how to manage a land to maximize the ability of it to recover after these multi-year droughts are really important. And so thinking about thresholds and how the ecosystem bounces back after these droughts is really important. And another thing to note here is you might wonder why, how are cattle actually going to graze under a lot of these shelters. And so what we've done is we've designed shelters that are easily removable. So when we have cattle that come into this area, we can take off all the roofs, remove all the experimental infrastructure, let the cattle graze the system so we get realistic grazing instead of just simulated clipping. And then once they're done, we can put these shelters back up to start blocking rainfall again. And so this is actually something that very, very few people have tried to do. And so it's been challenging, but actually really exciting, combining these two drivers of drought and grazing. Another thing that is special about this study is that we are looking at a wide variety of different variables in the experiment. So we are looking at soil microbial communities as well as plant communities. We're also looking at above ground plant growth and below ground plant growth. A lot of studies like this will just look at the above ground plant biomass and how that's affected by drought or by grazing. But a really critical component of the ecosystem is the root system. And so what we're doing is we are putting in something called a root ingrowth core, which is a cylinder mesh tube that we insert in the beginning of the growing season. We sieve out all the roots in the soil, and then we put that root-free soil into those cylinders in the beginning of the season. The end of the season, we take it all out, and we can measure how many roots have actually grown in those areas. And this gives us an idea of how drought and grazing are impacting root growth, because that's a critical component of how the system recovers after drought, having those below ground reserves.
Okay, so here you can see we've got these mesh bags that we've inserted into the ground. These actually go down 20 centimeters. And what we're doing here is we filled them in with kind of pure soil, so there was no roots growing in them. And now they'll stay in the whole growing season, and the roots will grow in from the side. And so we'll get a measure of how much below ground root production is happening in each one of our rainout shelters.
And so also looking across different trophic levels from microbial up to the plant level. Then we're also investigating how grazer selection actually changes with these different drought and grazing management strategies. So we're actually conducting this experiment at 2 different northern mixed-grass prairies, and these prairies are often thought to be very, very similar or identical even when we're thinking about how to manage these systems. And so one of the advantages of this project is that we're doing the exact same thing at both sites. We have the exact same measurements, the exact same treatments at each site, and we can see is this a viable assumption that all northern mixed grass prairie acts the same. We suspect that it doesn't. So, for example, here in Fort Keogh, we have very, very little sagebrush across the landscape. And down in our site in Thunder Basin, we have lots of sagebrush. And so one thing we can do is compare how drought and grazing impact the system with high sagebrush and with low sagebrush systems. And this can have important implications for things like fire management, where because fire takes out big sagebrush, takes a very, very long time to recover.